Hi, welcome once again to our YouTube channel. It's nice coming along with us. Thanks for subscribing to our channel. We really appreciate you. Today we quickly want to take a look at the 2025 Waec Animal Husbandry Practical. We want to look at the specimens that Waec has chosen to release for the Animal Husbandry Practical for the year 2025. So we'll be looking at the specimens, we'll talk about them, talk about their characteristics, their properties. We'll look at a whole lot of things, their uses, how they are made applicable to what animal husbandry is. So we'll be listing all of the specimens first and foremost before we start talking about them one after the other. So here we are starting with the Specimen A. Specimen A. And our Specimen A is wood shavings. Wood shavings. Our Specimen B, we have it to be beef. We have our Specimen C to be leather, and our Specimen D, according to the list, is the crop with its contents. Crop of a domestic fowl, crop with its contents. All of the contents must be intact. So the contents, crop of a poultry. And Specimen E, what we are having there is fresh liver. Fresh liver from a ruminant. Fresh liver from a ruminant. And then we have our Specimen F to be the hoof of an animal. Hoof. While we have our Specimen G this time around to be weighing scale. Weighing scale. And our Specimen H, as it is an egg candler. Egg candler. That is what we'll be using for our Specimen H. And then we have our Specimen J to be thermometer. Thermometer. And we have our Specimen K. Our Specimen K happens to be the hypodermic syringe. Hypodermic syringe. That is what we are having as our Specimen K. And then our Specimen L is cheese. We have our Specimen L to be cheese. Our Specimen M is milk. Our Specimen M is milk, and it should be labeled. Waec has instructed that we label our Specimen M, which is milk. And then we have our Specimen N to be horn. And lastly, we have our Specimen P to be fresh. We have it to be fresh Lucena leucocephala. Fresh Lucena leucocephala. Fresh Lucena leucocephala. That is our Specimen P. So these are the list of specimens that Waec has released for this year's Animal Husbandry Practical examination. For A, we have wood shavings. For B, we have beef. For Specimen C, what we have there is leather. For Specimen D, we have crop with its content, the crop of a poultry, a bird, the content of the crop. And then for Specimen E, we have fresh liver from ruminant. Specimen F, we have hoof. Specimen G, what we have there is the weighing scale. Specimen H is the egg candler. Specimen J is the thermometer. Specimen K is hypodermic syringe. We have Specimen L to be cheese. Specimen M is milk, which should be labeled. And our Specimen N is on. And lastly, Specimen P will be the fresh Lucena leucocephala. So those are the list of specimens. Now we'll go into talking about each of these specimens one after the other. So without wasting much of our time, we'll move straight into talking about the first specimen, which is Specimen A. So our Specimen A We said our specimen A is wood shavings. Wood shaving, that is our specimen A. So what do you have to say about our specimen A? Now, wood shaving is a base layer with thick covering of straw. Wood shaving is a base layer of thick covering. Is a base layer thick covering of straw. It is at the outermost part of the wood that is usually scraped out. This particular part is a waste that is obtained when wood is planed. It is usually obtained when wood is planed or milled. That is how we get this particular part, when it is planed or milled using carpentry tool. So when you make use of carpentry tool, be it a saw or a planer, you will be able to get this particular part of the wood out. So that is what the wood shaving is. They are also, they are seen as thin small pieces of shreds of wood created from the planing or the milling of wood, like we said. Now, they are commonly used as they are used for so many things, but in the application of this particular series that we're talking about, using wood shaving for animal husbandry. Common uses of wood shavings. Common uses of wood shaving. Number one, it is used as animal beddings. It is used as animal beddings. When you actually have probably a poultry cage or an animal cage for your ruminants, you can actually lay these wood shavings at the base of your cage, so as to eliminate every form of dirt and waste that the animals produce, messing up the environment. So you can actually lay these beddings, you can actually lay the wood shavings as bedding in the animal cage to prevent every form of dirt that will be lying in the cage, causing it to smell. So it can be used as wood shaving, as animal beddings. Number two, it can be used for mulching. Used in the case of mulching, and this is when we actually lay it as a material applied to the surface of soil to actually bring about the conservation of soil moisture and improving the fertility of the soil. Used for mulching, that is a layer of material applied to the surface of the soil for conservation of soil moisture and fertility. So we can actually use wood shavings for all of this. Also, it can be used as packaging material due to their desirable properties. It can also be used as packaging material due to their desirable due to their desirable properties. So these are some of the uses of wood shavings. So let me just show us example of what the wood shaving, what it is and how they are being used. Actually gotten when wood is being scraped, or when it is being planed, when it is being milled. That is how we get this particular specimen. You can see it here. You can also have this here. This is another picture that can show us what wood shavings is. So that is about wood shaving our specimen A. Alright, so our specimen B now. Specimen B is beef. That is what we are looking at for our specimen B, beef. So let us see what the beef is about. The beef is the culinary name for meat. Beef is the culinary name. That's the adopted name for beef. So for the meat of cattle. Like we have other animals like pig having its own meat to be called pork. So the meat for cattle is called beef. Now it is prepared in various ways. Cuts are often used for steaks. It is prepared in various ways. Example, it could be cut. It could be cut in slices and prepared or used for steaks and used for steaks. When you cut them in slices, you apply seasoning to them, and then you apply some amount of heat to it while roasting it. It could also be cooked. It could also be cooked to varying degrees depending on one's desire, to varying degrees or temperature. Varying degrees or temperature. You can actually do that. Now, it is valued as a complete protein. Beef is valued as a complete protein. Beef is valued as a complete protein because it contains all the amino acids necessary for body growth. Because it contains all the necessary amino acids. All the necessary amino acids required for body growth. Required for body growth. And that is why this particular specimen, a beef, is actually very, very essential. Other minerals that you can find in this, apart from the amino acids, other minerals that you can find in, we have iron. It has a high amount of iron in it. It also has vitamins, which are very, very essential. It is an animal tissue. It is cut from the animal tissue. It is an animal tissue. Often from the muscle. Often the muscle, and it can be eaten as food, and can be eaten as food. So the beef is very, very essential. So this is what the beef looks like. You can see it here. You You can see that's a picture of beef. You can see another picture or pictorial representation of what the beef looks like. You can see them here. So that is about our specimen B. Specimen C, we said our specimen C is leather. Our specimen C is leather. So what do we have to say about our specimen C, which is leather? First and foremost, you need to understand that leather is a strong, flexible, and durable material. Leather is a strong, flexible, and durable material. It is a strong, flexible, and durable material that is obtained from tanning. That is obtained from tanning, from the tanning process of animal skin. From tanning of animal skin, or tanning or chemical treatment of animal skin. Or chemical treatment of animal skin. That is how we get this particular leather, and it is done, the tanning process is done basically to prevent the skin or the hide, so to say, from decaying, from animal skins and or hides to prevent decay. That is the major reason why tanning is actually carried out. Now, the skin, let me just tell us the difference, the simple difference between the skin and the hide. Skin is gotten from small animals or smaller animals. Smaller animals like goats, pig, let's say sheep, etc. While the hide is gotten from larger animals, animals like we have the examples here to be, let's say cattle, we have buffalo. All of these are examples of animals that can give us the hide. So the outermost covering of a small animal like the goat, the pig, the sheep, deer, alligator, etc. Those are small animals that actually produce skin. But when we talk about hide, they are made from bigger animals like the buffalo, like the rhino, cattle, and the rest of those. Now, there are different types of this particular leather, of leather types. Now, example, we have the first one there to be full grain leather. So you could be asked for the examples. Full grain leather, that is one. We have another one which is called the top grain leather. Top grain leather. We have another one which is actually called genuine or premium leather. Genuine or premium leather. We have another one which is called split grain leather. We have another one that is called so those are the examples that we have there. Those are the major examples of the types of leather that we have. So we could also do this. We could also talk about manufacturing processes. Talking about the manufacturing processes now, we say that, okay, manufacturing processes, there are majorly processes for leather. It could be more than 3, but the very important ones there, we have them to be 3 in number, and these are the things that I will be listing now. The first one there is actually what we refer to as the preparatory step. So it is the preparatory stage. The preparatory stage, that's the first one. And then the second one is where the tanning process comes out properly. Tanning, that is actually where chemicals are being applied to treat the leather. And then the third one is what we refer to as the crusting. The crusting. So we'll get to understand what crusting is shortly. And so, like I said, sometimes we could have this fourth step, which is usually called the finishing. But this particular step is not usually done to all types of leather. So those are the 4 major manufacturing processes of leather. So like we have said, let us quickly see, what do we mean by tanning? Tanning, we have said that already. So tanning is the conversion of the skin and the hide to processed leather. Tanning is the conversion of skin and hide to processed leather. So then the other one that I made mention of, which is crusting. Crusting here is talking about the process that turns, or that things, it helps to thin and lubricate the leather. Crusting is the process that thins and lubricates. It thins and lubricates the leather. So those are the major manufacturing processes of leather, and this is example of what we are talking about here. This is an example of a leather. You can see the finished product here. That is what leather looks like. This is another example of leather here. You can see it. These are finished products that have been converted already to leather. Tanning has been carried out on this example. This is another framework of leather. You can see leather shoe, leathers, and the rest of those. So that is what leather is about. So we move to specimen D now. Specimen D, and that is the crop with its contents. The crop of a poultry bed with its contents. That is our specimen D. So let us quickly look at that. What do we have to say about that? Now, the crop in poultry beds, the crop is a specialized thin-walled pouch. The crop is a specialized thin-walled pouch that acts as a temporary storage site or area for food. That acts as a temporary storage site or area for food or grains that have been eaten by the poultry birds. Now, It is located in the esophagus. It is located in the esophagus or the gullet. It is located in the esophagus or the gullet. It is essential as an enlarged pouch that plays a role in digestion and gut health. It is very essential. So it is an essential component in the poultry birds. So it is essential. It is essentially an enlarged part that plays a role in digestion. It plays a role in digestion and gut health. Will tell us how that is done shortly. Now, it stores food temporarily, like I said earlier on, allowing birds to eat quickly. It stores food or their grains temporarily, allowing birds to eat quickly and more, and to eat more, to digest later, to eat more to digest them later. It holds food till it is ready to be released to the stomach. The crop holds food till it is ready to be released into the stomach. Very, very important. Now, the stomach, well, let me put that here, which is also called the proventriculus. Which is also called the proventriculus, as well as the gizzard and the gizzard. That is the milling instrument that is found inside the birds for further digestion. So this you can see now that the crop is very, very essential. In the crop, there is initial breakdown of food. Yes, in the crop, there is initial breakdown of food. In the crop, there is initial breakdown of food. Then also molding. We have breakdown of food, including the softening and swelling of the grains that have been eaten. So these are the things that happen in the crop, or what the crop itself look like. So let me show us a picture of what you are talking about. This is the picture of the crop. You can see this poultry bed here. You can see this part of the body of the poultry bed. So when the food comes from the esophagus, it lands first into the crop before it moves into the proventriculus and the gizzard. So that is what the crop there looks like. You can see this is another picture of the crop. You can see it here as well. You can see the crop here. You can see it labeled here. That is what the crop looks like. And so we have that here as well. This is when it is cut. When the crop is cut from here to this place here. Let me show you what I'm saying about what I'm talking about. When it is cut from this plait here in the throat to the tip of this proventriculus. That is what the gizzard will be looking, the crop will be looking like. It will be looking something similar to this. That is the crop. So we have a specimen E now. Specimen E, which is fresh liver. Fresh liver from ruminants. Fresh liver from ruminants. That is what we have as our specimen E. So what do we have to say about this? Looking at the fresh liver, we say that the liver helps in the synthesis and metabolism of fat. Liver helps in the synthesis and metabolism of fats. The liver breaks down, balances and creates nutrients from blood that passes through it. It breaks down, balances, and creates nutrients. From the blood that passes through it. The liver is a bile. Let me describe the liver now. The liver is a bilobed organ. It has two lobes. That is why we said it is a bilobed organ that lies ventrally. It lies ventrally, that is below, and posteriorly, talking about in the rear side. In the rear of the heart. And it is closely associated with the spleen. The right side lobe is usually larger. The right side lobe of the liver is usually larger in size than the left. Usually larger than the left lobe, and also it is involved in the secretion of bile. The liver is actively involved in the secretion of bile that is found in the gall. Secretion of bile in the gall bladder. That is very, very essential. Liver is a nutrient dense food. Liver is a nutrient dense food. Is a nutrient dense packed with essential vitamins. It is packed with essential vitamins and minerals. Packed with essential vitamins and minerals, particularly the vitamin C. particularly vitamin A, vitamin A, vitamin B12, which is cyanocobalamin. We also have it containing iron and folate. Iron and folate. It is a good source of protein. It is also a very good source of protein. So these are the things that we need to know about the liver. It is very, very essential. It helps in the synthesis and metabolism of fats, breaking down nutrients that pass through the blood. Also, it is responsible for essential vitamins and minerals, particularly vitamin A, vitamin B12, cyanocobalamin, iron and folate. It is a good source of protein. Describing the liver, we said that it is a bilobed organ that lies ventrally, that is below and behind the heart, and that is where you find it closely associated with the spleen. So this is a picture that can show us what the liver is looking like. You can see that this side of the liver is larger than this side here. So that is what the liver looks like. So this is another picture of the liver. You can see it's a labeled diagram of the liver now. You can see it having the hepatic vein here, and then this is the liver. We have the gallbladder here. This is where the bile is being secreted. This part here is the gallbladder. That is where the bile is being secreted. So we have the hepatic vein and the hepatic artery, and then the portal vein. So that is basically what the the liver is looking like. So we have this as another diagram to show us what the bile is. You can see it here. So this is the liver. To show us what the liver is, this is the liver. We can see this part here larger than this part here. We can see the gallbladder directly underneath it, and that is where it produces its bile. So that is basically what the specimen E is about. And now, which is our specimen F. Specimen F, and that is the hoof of an animal. The hoof of an animal. So what do we have to say about the hoof? The hoof is a hard protective covering on the foot of certain animals or mammals, like the horses, the cows. The hoof is a hard protective covering on the foot of certain animals, on the foot of certain mammals, like horses. Now, okay, horses, cows, goats, etc., and they are often called the ungulates. Often called the ungulates. These animals are called ungulates. The structure is composed of keratin, that is the active component in that hoof. The hoof is composed majorly of keratin. It's composed of keratin and similar to human nails. Similar to human nails or hair. It is similar to human nails or hair, as well as the claws of some other animals or claws in other animals, providing protection and permitting locomotion on various terrains. It provides protection. It provides protection and permits locomotion on various terrains. A disease that affects the hoof surrounding, a disease that can actually affect the hoof surroundings of an animal is a foot rot disease. A disease that can affect the hoof surrounding of an animal is the foot rot. Disease. The foot rot disease, and this particular disease is contagious, It is formed caused by a bacteria. Contagious and caused by a bacteria. Now, it can result to lameness. This can result to lameness or prevention, inability of the animal to walk. It can also result to swelling if untreated. If left untreated, it can result to swelling. In animals like horses, their hooves can be protected using a hoof horseshoe. In animals like horses that are usually used for races, their hooves can be further protected using a hoof horseshoe. So let me show us what I'm talking about. This is what I'm talking about here. You can see this is what the hoof looks like. You can see this place here is the hoof of the animal. That's the feet of the animal, of these types of animals that we have made mention of. That is what the hoof looks like. So this is another picture to help us understand what you are seeing. Now look at this. Now we can see here, that is the hoof of the animal. Now looking around here, now we can see that there is something here that looks like a metal. Here underneath the feet, this thing that is down here is what I refer to as the hoof shoe, the hoof horseshoe. This thing here, you can see that it is attached to the hoof. Let me show us another picture to help us understand that. Okay, look at this very well. Now you can see this particular part of the picture. You can see that it looks like it is nailed to it. Yes, that is the hoof horseshoe that we are talking about. You can see what it is written there, the horseshoe. So that is about that. So we are moving over to our next specimen now, which is specimen G. Specimen G, which is the weighing scale. So what do we have to say about the weighing scale? The weighing scales, they are of different types. So weighing scales are equipment designed to help take measurements. Weighing scales are equipments or instruments designed to help take measurements of different materials, measurements of different materials ranging from farm produce to even the farm animals themselves, ranging from farm produce materials. There are three major types of weighing scale. The types now. Types of weighing scale. First one, and they are classified based on how they look. The first one is the mechanical scale. They are classified based on their principle of operation. The first one is the mechanical scale. We have the second one to be called the digital scale. Digital scale. And we have the third one to be called the analytical scale. So these are the major three types of the weighing scale that we have. I'll show us pictures of this shortly. Their principle works on the effect of force of gravity. Their principle or the mode of operation of this equipment works on the effect of the force of gravity. So it is the force of gravity that actually pulls the object to lie on the scale for the weight of that object or that material to be actually measured. It is used on farm to take a record of the growth experienced on different animals. Please close the door. It can be used on farm to take a record of the growth experienced on different animals. Can also use it to measure the quantity of food or feed that is given or that is applied to animals on a regular basis. So these are the things that we need to know about this particular specimen. So this is a picture of what we are talking about. This here is an example of what we refer to as an analytical balance. It is also a weighing scale. You can see it. You can see how it looks. So that is what we refer to as a weighing scale. We have other examples like this one. This one is also a weighing scale. It can be used to measure the weight of substances. Here's another example of a weighing scale. You can see them. This is another example of a weighing scale. So the next specimen now is our specimen H, which is egg candler. Specimen H, which is the egg candler. Egg candler, that is our specimen H. So what are we saying about the egg candler? This is a device that is used for actually detecting or testing eggs. This is a device that is used to test the viability of eggs. Device used for testing the viability of eggs. It is used to test the viability of eggs, particularly during incubation. Particularly of eggs, particularly during incubation. Particularly during incubation. That is what that particular instrument is used for. They can still during incubation to detect if the eggs can still hatch. Yes, it is used to observe the growth and development of embryo inside an egg. It is used to detect, to observe. It is used to observe the growth, and development, of embryo. The growth and development of embryo inside an egg. Inside an egg, using light shown on the shell of the egg. Using light shown on the shell of the egg. Yes, that is the application of that particular instrument. It makes use of light to actually get the substance to be shown. In the past, candle and bulb constructed in boxes. In the past, candle and or bulb constructed in boxes were used as candlers to check how the egg is doing. They were used as candlers, but today we have electrically powered candlers. But today electrically powered candlers, there are electrically powered candlers which have been designed. Today there are electrically powered candlers designed to operate using LED. They make use of LED lights or incandescent bulbs as they have been adopted. So today we have this type of candlers now, the ones that they actually have their own LED light, source of light, and with that they are able to check the viability of the eggs. This is an example of what we are talking about here. This is an egg candler. This is a modern egg candler. You can see this one is powered by a battery. You can see this is the battery. The battery fits into the battery case and it is put in here, and then you just switch it on, having your bulb on it. So when your egg on the candler, this is the source, the part where you put the egg. So when you place your egg on it and you switch the candler on, this is something similar to what you will be seeing in the egg. So that tells you, or it shows you how viable the egg is, the stage at which the egg is at that very moment. It doesn't have any side effect to the egg or the content of the egg. So this is another example of the candler. This is another example. This one here takes just one egg per time, while this one takes multiple eggs per time. That's another example of a candler. You can see this is more or less somewhat what I discussed earlier on as an ancient system of checking the viability of an egg. So this is just something that looks like a bucket or a cylindrical container where a candle has been lit inside it. Then a piece of cardboard was placed on the cylinder with a hole on it. On the hole is where the egg is being placed, and that is how they check the viability of the egg. So that is that about the candler. Next specimen we have there now is our specimen J. Specimen J, which is the thermometer. That is our specimen J. The thermometer is a thermal instrument. It's an instrument that is used to measure temperature. Is used to measure the degree of hotness, the degree of hotness or coldness, degree of hotness or coldness of a body, or substance. It measures the boiling and freezing. It measures the boiling and freezing points during experiments. It can be used to measure the boiling and freezing points during experiments. Now it measures temperature ranging between, it is used to measure temperature ranging between minus 10 degrees Celsius and about 110 degrees Celsius. It is used to measure temperature range of that. The major types that we have, let me just put them here. Types of thermometer. Number one, we have the digital. We have the digital thermometer. We have the ear thermometer. We have the strip thermometer, as well as the infrared thermometer. So those are the examples or the types of the thermometer that we have. So quickly, let me show us what the types of thermometer that we have are. This is an example of a thermometer. This is the digital thermometer. We can see it has its screen here. So it is digital and it makes use of infrared as well. So in the front of the thermometer here, there is a beam that shoots a ray to the object or to the body that is to be measured, that the temperature is to be measured, and then it shows the reading or the temperature of that body or of that substance on the screen here. So that is a digital thermometer. This is another type of thermometer. This is a clinical thermometer, the one that is used in the laboratory. You can see them of different types and sizes. So this is how the temperature ranges. You can see, so it ranges from minus to about 110, 120 thereabouts. So that is what thermometer looks like. Specimen K, hypodermic syringe. That is our next specimen, our specimen K, the hypodermic syringe. So what is an hypodermic syringe? This is a long tube used with a needle. So this along with a needle at the tip of it are used for various medical tasks, including medication administration. They use it to apply medicines, particularly when it talks about injection. Medication administration. Yes. Also, the administration could be, we could have it to be intravenous. It could also be subcutaneous. It could be subcutaneous and also intradermal. Intradermal injection. All of these are the types of ways through which you make use of this particular substance. Could be intradermal. For vaccines, now it could be used. It could be used for vaccines. It could be used for vaccines, for medications and allergy tests. Vaccines and allergy tests. So we have said that previously. So hypodermic there means relating to the parts beneath the skin. Hypodermic there. Hypodermic means relating to the parts beneath the skin. To the parts beneath the skin. That is what the hypodermic there is talking about. It has the ability to retain liquids. This particular syringe, it has the ability to retain liquid and blood. It has the ability to retain liquid and blood in it up to years after use. So that is what the hypodermic syringe is actually looking like. So we have different types and sizes. It could be of different sizes, e.g. it could be, we have 1 ml, we have 2 ml, we have 5 ml, we have 10 mils, syringe, etc. So they could be of different sizes. That is what the syringe is looking like. So this is an example of the syringe. That's the hypodermic syringe. You can see them of different sizes here. You can see them, they are of different sizes. You can see, so this is what it looks like in the label. So at the tip of the needle here, at the tip of the needle is here where we have the bevel. The bevel is here, it has the shaft and the lumen. This is the part that is inserted into the body, and here it has the needle hub, the part that sits directly on the syringe. You can see it. So this part here sits directly on the syringe. You can see that part here. It sits directly on the syringe. That is the part that sits directly on the syringe, and then it has its scale. The scale, that's the grading, like the one we saw previously, like this one here. Like this one here, you can see that it has grading. It is marked 1, 2, 3, 4, 5 to 10. So this is an example of a 10 ml syringe. This one here is an example of a 10 ml syringe. So using this now, we have different examples like I've shown us here. So this is a labeled diagram of the syringe. We have our next specimen, specimen L. Specimen L to be cheese. Specimen L is cheese. That is our next specimen. So what do we need to say about cheese? This is a type of dairy product produced in range of flavors. This is a type of produced in a range of flavors. In a range of flavors. It is produced in a range of flavors and texture and forms. Flavors, textures, and forms by coagulating milk. By coagulating milk protein. By coagulating milk protein, which is called casein. The milk protein called casein. That is the name of the milk protein. It comprises of protein, like we have said, and fat from milk. Cheese is rich in proteins and fats of milk. Yes, it is soft. It is a soft product with a mild sweet taste and milky flavor. It is characterized by a soft, mild, sweet taste. By a soft, mild, sweet taste and milky flavor. And milky flavor. Yes, it is very, very sweet. Cheese is a nutritious addition to the diet. Cheese is a nutritious addition to the diet. Is a nutritious addition to the diet, and then it provides valuable nutrients like calcium. It provides valuable nutrients essential nutrients like calcium, protein, calcium, proteins, essential vitamins, like vitamin A and B12, the cyanocobalamin, which supports the bones and the brains healthy. It supports the bone and the brain health and overall well-being, which supports the bone and brain health, supports the bone and brain health and overall well-being of the body. That is what this particular specimen can do, the cheese. It is a very, very important addition or nutritional addition to the diet. It is a dairy product that is produced with different flavors and it has different textures and forms. Actually, it is done with the coagulation of milk or casein in milk. So like we said, some of the nutrients that are found in it, we have calcium, proteins, essential vitamins like the vitamin A, the cyanocobalamin, and they are very, very good at supporting bone and brain health as well as the overall function or functioning of the body. So this is an example of what cheese looks like. Here is an example of what we have as cheese. So when we look at this now, we say we have cheese. This is another example of a cheese. This is just a slice of the cheese. You can see it. Now locally, this is what it looks like in our environment here, particularly the Yoruba, as they call it wara. That is what it looks like. So that is what cheese is. So you can see it when it has been processed and fried. That is what it looks like. You can see it here. That is what it looks like. Locally, this is what it looks like when it is being prepared. So that is about our specimen L. Specimen M, milk. Specimen M, which is milk. It is to be labeled milk. So what is this? Dairy products. This is another dairy product that is formed from farm animals. Another dairy product formed and gotten from farm animals, like cattle, pig, sheep, goats, etc. All of these animals are able to produce milk. They are able to produce milk in their mammary gland. From the mammary gland of farm animals. Okay. The animals produce the milk in their udder. They produce the milk in their udder, and then they are extracted from. Okay, that's what I said here. They produce the milk in their udder and is extracted from the mature females, from mature female of these animals, from the mature females. Some of the animals are reared specifically for this purpose. Some of the animals are reared specifically for the purpose of milk production. For the purpose of milk production, we have that to be the function of, or the reason why some of these animals are actually reared. Milk is rich in protein. Milk is rich in protein. Milk is rich in protein, calcium, etc. It is processed into cheese, yes, like we saw cheese some minutes ago. This is what is used for that. It is processed into cheese, and apart from cheese, you still have some other things that can be gotten from the milk. Example, we have yogurt. So our milk can be processed into cheese, into yogurt. Milk that has not been pasteurized could contain diseases. So it is very, very important to make sure that the milk goes through the normal production process. Milk that has not been pasteurized could contain diseases, could contain disease-causing pathogens. So we should be very, very careful when we actually feed on these substances. So that is about the milk. So this is what the milk looks like. You can see milk in a jar. That's milk in a jar. You can see how white it is. This is milk again, freshly gotten from the animals. You can see the animal in the background of that particular picture there. So this is how it is being extracted. You can see this particular instrument that is used to extract the milk from the udder of the animal. So that is about the production of milk. You can see the udder of the animals in this particular picture here. You can see how big the udder is. So the tip of the udder, the teeth is here. They attach the machine that is used to extract the milk, and then it is processed. So our next specimen now is going to be specimen N. Specimen N, and our specimen N is horn. Specimen N is horn. That is our specimen N. So what is horn? That is what we want to look at right now. So when we talk about horn, horn is actually a hard permanent outgrowth, often curved and pointed, that is found on the part of the head of an animal. Okay? A horn is a hard permanent outgrowth, a hard permanent outgrowth, often curved, pointed, often curved, pointed, and found in pairs, on the head of some animals. Yes, a horn is a hard pointed, we have said that, is a projection on the animal's head, e.g. cattle. Example, the cattle, the goats, deer, etc. Horns are made of keratin and other proteins. Horns are made of keratin and other proteins. They are made of keratin and other proteins surrounding a core of bone. Surrounding a core of bone. Surrounding a core of bones. Yes, they are distinct from another. These horns, they are distinct from the horns of others which are shed and regrow actually. They are distinct. They are distinct from others, from another's, which are often shed, and they regrow annually. So they are often seen on the head of animals. This is what we are talking about here. This is an example of a horn. You can see it. This picture here is an example of a horn that has been actually used it has been used or processed into an instrument, a musical instrument or a horn. So you can see it. So at this part here that has been cut, they blow into it and it brings out sound. You can see it. So this is another example of a horn on an animal. You can see it. This is the animal's head, and then you can see the horn curved. This is what we refer to as the horn. You can see it. So this is the horn. You can see it. So they are of different types like that. We have them on different animals. You can see this is another animal with its own horn. You can see its own horn here. You can see it. So they are of different types. This is another animal with its own horn. This is another animal here again having its own horn. You can see this as well. So there are different animals and different animals have different horns. Our last specimen now is a specimen P. Specimen P, and that is the fresh Lucena leucocephala. Lucena leucocephala, that is the scientific name of this animal, of this plant. That's the scientific name of this plant. So when writing botanical names, you don't join the underline, and it is only the L that starts the scientific name, like we have written here now. Only the L is written in capital letter. Every other thing in the scientific name or the botanical name will be written in small letter or in lower case. That is what that particular specimen that we're talking about is. So that is how the name is written. So that's the Lucena leucocephala. So what is this? First and foremost, let us classify this organism. So it belongs to the kingdom Plantae. And the phylum to which it belongs is the Trachyphyta. Its class, it belongs to the Angiosperma. The order is Fabales. The family there is the Fabaceae. We have its genus, like the name implies. We have the genus to be the Lucena, and then the species is the Leucocephana. leucocephala. That is its scientific name. That is where the scientific name is gotten from. So here now, we said leucocephala is a small, fast-growing tree. This is a small, fast-growing tree. Is a small, fast-growing tree that is popularly known as white lead tree. Popularly known as white lead tree. That's a popular name, or it is also called the horse tamarind. Horse tamarind. Those are some names that have been given to this particular crop. It is used for a variety of purposes. It is used for so many purposes, e.g., it is used for various purposes. E.g., for fencing. It is used to make fences. So it is used for fencing, for soil fertility, it is also used as firewood. It is used as firewood. It can be used for timber and livestock fodder. Timber as well as livestock fodders. So it can be used as feed for animals. The tree grows up to 7 meters height. Let me put that here. It grows in height to about 7 to 8 meters. Its bark is gray and cracked. Its bark is gray in color and usually cracked. Its branches have no thorns. Each branch has about 6 to 8 pairs of leaves. Its branches have no thorns, with about 6 to 8 pairs of leaves. Pairs of leaf stalks. Now, each of these leaf stalks bear about 11 to 23 pairs of leaflets. Leaf stalks carrying about 11 to 23 pairs of leaflets. I'll show us what we are talking about shortly. Now, this is a legume that is used for forage. Like I said earlier on, this particular crop is a legume. It is a legume used for forage and fodder. Used for forage and fodder, like I said earlier on, and it is an important source of high protein in animals. It also helps in the production of green manure. Also used in production of green manure. It is also used in production of green manure. Also, for humans, the young pods are edible and occasionally eaten with peanut sauce. Also eaten by humans with peanut sauce. So we can actually have that with peanut sauce. Yes, it is also used as a pulpwood in paper production. The uses of this particular tree, this Lucena leucocephala, is very, very numerous. It is also used as pulpwood in paper production. We also have it used for its medicinal properties. It is also used extensively for its medicinal properties. So these are some of the functions or some of the things that this particular tree can be used for. So we need to understand that. So all of these that I wrote here, they are the uses of this particular crop. I said from here, I started talking about its uses. From here, I talked about the uses as well as what we have here. All of this down here also are talking about the uses of this particular crop. So let me show us what this crop looks like. This is what the crop looks like. That's a plant. You can see it. It has, okay, let me show us this picture first. You can see that it has a pod. This is another picture of it. You can see that it has a pod, and when the pod is being broken, this is what the seeds in it look like. So it is these seeds that can be eaten by animals. So the leaf of this particular plant can be used as forage. We saw all of the things that we wrote about it. It can be used as forage. It is a legume that is used as forage or fodder for animals because it contains high protein. It is also used in the production of green manure and biomass. For humans, it can be edible. It is also used as pulpwood in paper production, as well as it being used for its medicinal properties. So these are the things that we can say about this specimen. This is as far as we can come with this particular tutorial in preparation of the Waec 2025 Animal Husbandry Practical. I encourage you to please try as much as possible to go through all that has been discussed. Go through them once again. Take out your pen and jot down as you listen to this and as you watch this video clip. Try as much as possible to understand everything that has been discussed. And peradventure you have any question that you still need clarification on, do not hesitate to send the question to us right there in our comment section. We want to hear from you, so please kindly do so. For those of us that are yet to subscribe to the channel, please do so. Subscribe to the channel. Subscribing to the channel has a whole lot of benefits to offer you. Once you subscribe to the channel, put on the notification button so that you will be easily notified when subsequent uploads are put up on the channel. We promise to put up very interesting content, and as the exam is going on right now, you'll still be looking out for some other experimental practical tutorial sessions talking about those that will be coming up for the biology, chemistry, agric science, even in the NECO session. So please stay tuned to look out for the videos that will be putting that will be uploaded to you. Thank you very much for subscribing to our channel and for coming along with us, and we wish you success in your exam. Bye for now.